One variable data, distributions and measures of center and spread. That is a category on the SAT. When you go into the question bank, they have this category. What does it mean? You're going to find out by doing practice problems with me today. We're going to be doing 39 questions within this broad category. I've broken them up into 39 types, and we'll do one for each type. This is level easy. We'll get to the M's, which are level medium, and then the H's. This is the first one there. So let's try these out. And if you know all these, you'll be golden for this type of question. Which of the following is true for this data set? So we have 2 to 24. So the range there is 22. That's true. We look at our answer choices. D is eliminated. Then we see that 2 is true for everything because all are correct. We can check it and we see the median is 11 because it's the two middle numbers there. So it'd be 22 divided by 2. Because there's an even number of numbers, we take the two middle numbers. If there were 7 numbers, we would just take the middle number itself. Mode is the most common number, so 7 and 7 comes up twice, and nothing else comes up twice, so that's also true. And then mean equals 14. To find the mean, we would add them all together and see what we get. So we would do 2 plus 7, which is 9, plus 7 is 16, plus 15 equals 31, plus 23 equals 54, plus 24 equals 78 divided by 6, and that is not a mean of 14, so it's not going to be 4, so it's not A and it's not B, it has to be C. Okay, so this is a really straightforward question because they organized the numbers for us already from least to greatest, and the numbers are all pretty straightforward. Integers, whole numbers, nothing too crazy. So this one should be pretty straightforward for you. We'll try another question in the easy levels, all about frequency tables. Which frequency table correctly represents the data listed? And here's our data. We have 3 3s. So if we look, we have number 3, frequency of 9, number 3, frequency of 3, so it should be that one, because nothing else has a number 3, frequency of 3, except for this one here. So those are our two options right now. So we can eliminate C and D. Now, 4 6s, that's here. 1 7 there, and 2 8s there. That's the only one that fits all that, so it's going to be B as in boy. All right, so it's not too complicated. You just need to understand how frequencies work, and you need to understand that the number is the number, and the frequency is how often that number comes up. So the 3 3 is the same for both, but the other ones switch it up, and you just have to be careful with that. Okay, so now we're on category C within the easy level. So we have data set A, 55, 61, 63, 68, 68. Data set B, 35, 70, 72, 89, X. Data set A and data set B each contain 5 numbers. Okay, as we see, if the mean of the two sets are equal, what is the value of X? So if the mean is equal and they both have the same number of numbers, then that means the sum is equal. So let's find the sum for A and see what X has to be to make the sum for B the same. So 55 plus 61 plus 63 plus 68 plus 68. You can put that into Desmos. We'll do it here. So 55 plus 61 plus 63 plus 68 plus 68 is 315. Now let's subtract the other numbers. So we'll do 315 minus the other numbers, which are 35 plus 70 plus 72 plus 89. So we're left with 49 left over, so that should be what our X value is. And that would be B as in boy. Because we do that minus these numbers here. Okay, so you can put it into Desmos. It's pretty quick. If the numbers are smaller, there are fewer of them, you can just do it in your head. Desmos, you're just using the track. So now, so far, 3 questions, pretty straightforward. If you have questions on them, though, feel free to leave them in the comments. A restaurant has 12 tables and sells 98 meals on a given day. Which of the following can be calculated from the information? 98 meals, so we have a total and we have a number of numbers. When we have that, let's look at our choices. Median, we don't have the spread of the numbers, so we can't do median. Average number of meals sold, that would be it, because we could do 98 for total divided by number of things and get it. Range, we don't have a minimum or a maximum, so we can't do that. And the least, we don't have the minimum. So it is the mean or the average number of meals sold. This is just testing your knowledge of what you can get from certain pieces of info. Okay, and now we have category E, which is about reading a table to get spread data. The table to the left shows the square footage of 5 different houses. A 6th house with a square footage of 916 square feet is added to create a new data set. Which of the following accurately compares the means of the two data sets? So what I don't want you to do is to add it in, the 916, and then calculate. What you need to think about is how 916 is bigger than any of these numbers. So things are going to be shifting up. Okay, so how do we do this? So this is all shifting up. Let's look at our choices. The mean of the original data set is less than the mean of the new data set. So the new data set is bigger mean because it's pushing up the average with the 916. We didn't have to find the average to know that because we know it's going to be bigger if it's already bigger than all the values. So it should be A, but let's just check everything. The mean of the original data set is greater than the mean of the new data set? No, because the new data set is bigger. So it's not B, the means are equal. No, and D, there's not enough information to compare the means. No, because there is enough information. So it is A as in apple. If you have questions on how I did that without actually doing the calculations, feel free to ask, but think about how the number is bigger. If the number were in the middle of the numbers we're given, then it might be like, oh, maybe it is the mean, and we have to figure it out mathematically. But here, since it's bigger from everything, we know it's going to push it up. All right, so here we have another one. Double yolk eggs are eggs that have 2 yolks inside them. A student interested in chicken farming does a 6-trial study. In each trial, he examines 1,000 eggs. The bar graph to the left shows the number of double yolk eggs in each trial. What is the mean number of double yolk eggs for the 6 trials? So we're given the number of double yolks for each trial. So let's see, this is 20. I'm going to say this is 18. I'm going to say this is 35. This one is going to be 24. This one will be 30. And this one will be 26. Now I'm estimating on some of these, but the numbers are far apart enough that I think I can still find it, even if I'm off by 1 or 2 on a couple of them. So it'll be 20 plus 18 plus 35 plus 24 plus 30 plus 26 divided by 6, and we get 25.5. B as in boy again. Okay, so this one, just read the chart carefully, note the numbers down, and then you can just plug it in. Let's try our next one now. And you're seeing that these are pretty straightforward. Even though they feel maybe very easy, they will come up on the test. So it's still good to know them, and hopefully you know them mostly already. Box and whisker plots, people know a little less, so I'll just remind everyone that the bottom line on a box and whisker plot is the minimum. The top line is the maximum. The middle line within the box is the median. Everything starts with an M, right? And then this one here is the 75th percentile. And the bottom of the box is the 25th percentile. So the box plot summarizes 30 data values. What is the median of this data set? We're here. It's hard to read, but this is 10, 15. We go up, it's between 10 and 15, probably around 12. Our only possible answer is C, 12. So just remember what those lines mean within the box, and you should be fine on box and whisker plots, especially at this level. And now we have another frequency table. The table gives the results of a survey of 13 students on how many siblings they have. How many students have either 2 or 4 siblings? So number of siblings, there's 2 there, and there's 7. And then there's 1 who has 4. So that will give us 8 total, D. Because you just do 7 plus 1. And that is 8. Okay, now we're on to I. The table presents the data for the number of different colored socks in a drawer. How many more blue socks are in the drawer than red socks? All right, this table might look kind of similar, but it's different in the values of what it's asking for. How many are more blue socks are in the drawer than red socks? So blue socks, there's 35. Red socks, there's 20. So you just subtract and you get 15. Again, we're just reading bar charts, nice and clean, something that a 3rd grader can do, but still something that the SAT might test for. Okay, and now we have AJ, another table. There's a lot of tables in this one, so get used to it. The table to the left has the data for the average number of students per grade in a given foreign language class. Based on the table, how much less was the average number of students in Latin than in Mandarin? So this is the average number of students. It's like the last question, except instead of a bar chart, it's a table. So average number of students in Latin than in Mandarin. So we take Mandarin's total and subtract from it Latin. And that's going to give us an average of 6 different. So it's going to be A. B would just be if you put Latins down. C would be if you took Mandarins down. And D is if you took the sum instead of the difference. Okay, if you have questions on that, you know I would love nothing more than to answer a question. Now we're moving on to level medium. So let's see just how much it's stepping up for us here, right? Those were all pretty quick. The table to the left shows the distribution of ages of 25 students in a writing class. Based on the table, which of the following gives the correct order of the mean, median, and mode of ages? Okay, and then we have all these categories. Mode is less than median, which is less than mean. Mean is less than mode, which is less than median, and so on. So let's find the mode. That's the one with the highest frequency, so that'd be 7 here. So that's 21. Mode is 21. If you took the test, you could keep that in your head, but I'm just going to write it down for us all to see. Then we're going to have median. There's 25 students, so let's find the 13th student. So the first 2 are here, then the next 7, so we're at 9. Then 3, so we're at 12. So then 13 is right here. So the median equals 24. And then how do you find the mean? With a frequency table, you multiply each number by the number. Some people might want you to make the table in Desmos and have it work it out, but honestly that takes more time than just doing the math, and you can use Desmos to do the math. So 20 times 2 is going to be 40. 7 times 21 is going to be 147. 3 times 23 is 69. 4 times 24 is 96. 6 times 26 is going to be 156. 1 times 29 is 29. 2 times 30 is 60. Then we start adding. Now that we have that value, we can divide by 25 and get a value that is just a hair under 24, because 25 times 24 is 600. So this is just below it. I don't care what it is, honestly, because we're just comparing. So mean is less than 24. So then the mean is less than the median. So that would be here, or in B. So mean is not greater than median. We're going to take that out. Then the mode is the smallest of them all. So that's going to eliminate this one and this one. It's going to be D. Median is the biggest. Mode is the smallest. Mean right in the middle. All right. So now we're going to go on to category B within the level medium. Numbers again. The table to the left summarizes data values. What is the maximum value in the data sets? So again, it's all about not getting confused between frequency and the data value. The data value is what matters, not how often it happens. So the mode would be 33, and that comes up 40 times. But the maximum would be 37, which only comes up 5 times. So our answer is C, 37. A star for joy, you know. It's good to have some joy even when you're studying for the SAT. The table to the left summarizes data on size of apartments in a city. Which statement is true based on the table? So we have group A, sample size 500. They both have a sample size of 500. Mean is 560 for both of them. And then there's a standard deviation that's greater in group B than group A. The two groups are identical, almost, but the standard deviation is different. Group B contained the biggest apartment. We don't know that because we don't have a max going on here. The median in group B is greater than the median in group A. Again, we don't have enough spread information to know that. The size of apartments in group B has a larger spread than the size of apartments in group A. It would be D. Because of the standard deviation, that's telling us they're spread out more. If it's a bigger standard deviation, they're not clustered as much. If there's a small standard deviation, that means they're more clustered. So that 27 being greater makes it be D. So as you can tell, even in the medium, there's not that much math going on. It's just about understanding the concepts involved in distribution and centers of spread, or measures of spread and centers. Then we have this: the mean and median of the 6 numbers above are equal. Which of the following is not a possible value of X? So if the mean and the median are the same, let's first find the median, possibly. So we have 3, 5, we have 6 numbers going on. Right now, the median of these 5 numbers would be 15. And what they add up to is 12 plus 18 is 30. So we're going to do plus 13 plus 15 plus 15. So we have 30 plus 53. So we're going to have 30 plus 30. We're going to have 73 as our total. Now we're going to use these numbers to see what happens. So we have we have 17. We do plus 17. And that would give us 90. 90 divided by 6 equals 15. So we'd have a mean of 15. And in that world, 15 is the mean, right? Because we'd have 17 here. We'd have 12, 13, 15, and then another 15. So the mean would be the same as the median. It's not that. Then we can try 11. If we have 11, right, we're going to get 84. Okay, so in this world of 84, our new numbers are 11, 12, 13, 15, 15, 18, and our median is now between these two, and it's 14. Now 84 divided by 6 equals 14, so that one also works. It is a possible value. We're looking for what's not possible. Now if we have 14, our new sum would be 87. 87 divided by 6 gets us 14.5. And in this world we have 12, 13, 14, 15, 15, 18. And the middle number is here, and that'll be 14.5. So that's possible. So D should not be possible, and let's just check it to see what happens when we do D. So when we do D, we're going to be adding 5. We're going to get 78. 78 divided by 6 gets us 13. Okay? Then 13 is our new average, but when we order the numbers, we have 5, 12, 13, 15, 15, 18, and the median would be 14. And that doesn't work, so then the answer is D. D is not possible. This one's been the one that's had the most work so far, but it's still not too crazy, and if you can do it in the amount of time I just did it in, you'll be golden. Okay, so now we have category E within the medium level. The mean of the set of numbers above is what fraction of the sum of the 6 numbers? Okay, so they tell us there's 6 numbers. Now, what you don't want to do is add them all together, then divide by 6 and find it. We could do that, but we don't want to do that because there's 6 numbers, and the rule with mean is mean equals sum divided by numbers. So it's going to be equal exactly 1/6 of the sum. So our answer, without even doing the math, we should know is going to be 1/6. If it had been 5 numbers, it would have been 1/5. If it had been 12 numbers, it'd be 1/12. Now I'll do the math and show you how exactly it works. 2 plus 6 plus 5 plus 15. Honestly, you should just trust me, but I get it. I get it. You need to see it to believe it. Ye of little faith. 2 plus 6 is 8, plus 5 is 13, plus 15 is 28, plus 22 is 50, plus 62 is 112. 112 divided by 6 is equal to, anyone? You got it, 18 and 2/3. Now 18 and 2/3, 112 divided by 18 and 2/3 equals, let's just bring out Desmos since you don't trust my math here. We're doing this, we're going to do it the whole way. First we'll do 18 times 3 plus 2 to get an improper fraction, because then we can divide. So we'll do 18 times 3 plus 2, 56. So now we'll do 112 divided by 56 over 3. And look at that, it's 6. So it is just what I said, right? It's going to be 1/6. But again, if you can do it conceptually, it saves you a bunch of time and saves you from making silly mistakes that might have thrown off your answer. Now we're on to category F. A class of 10th graders has various heights. 12 students are below 160 centimeters. 15 students are between 160 and 170. 16 are between 170 and 180 centimeters. 9 students are taller than 180 centimeters. Which of the following is a possible value for the median? So first we have to find the total number of students, because they don't tell us. So we'll do 12 plus 15. And then if we look at our answer choices, we have basically one within each category. So we have to find which category it's in. Plus 16 plus 9. That'll be 25, 40, we have 52 students. Now 52 students divided by 2, we're looking at the 26th and 27th student. So between 26 and then someone 27. So the 26th student, the first 12 are there. Then the next 15 are in the next category. So that takes us to the 27th student. So 26 and 27 are between 160 and 170. So our answer should be B, because that's between 160 and 170. Okay, so you need to find the median by using this, like, it's almost like a frequency table written out for us. Okay, now we have G. Dataset A is a series of 7 consecutive even integers. If P is the mean and Q is the median, what is the value of Q minus P? So in this one, our answer is going to be a big fat 0, a goose egg. Why? Because we have 7 consecutive even integers. If they're consecutive, that means they're one after the other and they're even, so they're 2 apart every time. And I'll show you what happens. Let's start with 3 numbers. Let's say our numbers are 3, 5, 7. Because they're evenly spaced and there's an odd number of numbers, our mean and our median would be the same, it would be 5. Now let's say we had 3, 5, 7, 9. This would throw it off, would it? No, it would not throw it off. Because 5 and 7 now are going to be used to find the median, and that'll be 6. So as long as they're evenly spaced, they're always going to equal each other. 11, that would make it now be 7. So we have 1, 2, 3, 4, 5, and then we're going to have 13 and 15. So these cancel out to get the median. And because we have them equal spaced, the mean will be the same thing. And you can work it out and see. I'll do it. I mean, with 3, 5, 7, it's pretty straightforward. So I'll just do that to show you. It's going to be 15 over 3, and that's going to be 5. And it's going to keep working that way. If they hadn't said consecutive, we couldn't do this problem. And the even actually doesn't matter. It could be odd. It could be just regular integers. It'll work out either way. Now we're on to the category H, which is finding a change. So the square footage of 20 houses on a street form dataset A. The largest house is found to be 100 square feet larger than originally reported. What value remains unchanged in the dataset? So because it's larger and nothing else has changed, the range is going to go up, right? Because it minus the minimum will be different now. The mean will change because we're changing the sum, and the standard deviation will change because the spread's a little more spread out. But the median won't change because the median only depends on the 2 middle numbers. So the answer will be median. All right, we are just moving and grooving through these. Which of the following statements about the means and medians of dataset A and dataset B is true? A, only the means are different. So if you look at them, they're identical except A has a 30 added on. So that would definitely be different. Only the medians are different. The medians are not different actually, so it's not going to be B. So I'm guessing it's going to be A, but let's check the other options. Both are different? No. And neither are different? No, because A is different. So our answer is A. Again, any math to do? Not really. It's just about reading the chart, or here the data sets, and understanding means versus medians. You have to trust yourself so you can move quickly through it. In the table to the left are the recorded average prices of a gallon of milk at different grocery stores. What is the median of the milk prices from these 5 stores? Okay, median. I love median because you don't actually have to do the math. You just have to organize things. And it's almost organized in order, but it isn't. This is the minimum. So I'm going to cross that out. I like to go minimum, maximum, minimum, maximum. So I'm crossing out the minimum. Then the maximum is here. That one's gone. Now I'm going to cross out the new minimum and the new maximum. So then I'm left with 4.561. My answer is B as in boy. Okay. Again, moving and grooving. We are on a roll here. Okay, so now we have some dot plots going on. Each dot plot shown represents the number of pencils bought by students in two different classes. Which statement best compares the standard deviations of the numbers of pencils bought by students in each of the classes? If you look here, they're identical in terms of the number at each thing. It's identical shapes, but the numbers at the bottom are different. We have 3, 5, 6, 8, 11, 14. We have 1, 5, 6, 8, 11, 17. So these bottoms and tops are higher, right? The max and min there. A, the standard deviation of the number of pencils bought by students in class A is less than the standard deviation of the number of pencils bought in students in class B. B, the standard deviation of the number of pencils bought by students in class A is greater than the standard deviation of the number of pencils bought by students in class B. Or C, the standard deviation of the two classes is equal. Or D, there's not enough information. So we can tell actually that it's going to be A, because class A and class B are identical, except here it's sort of closer because it's 3 and 14. The range is only 11, and everything else is the same. And here we have a range of 16 with everything else being the same. So either way, this one has a bigger range. Now, if these dots were moved around, then we'd have to do calculations to find it, and that's not something the SAT would ask you to do. So it's going to be about this change here, this spread being opened up by the 1 and the 17. So if you have questions on this one, let me know. It gets more conceptual here, but again, the math itself isn't too crazy. Now we have this one here. The table to the left shows the number of students at a school taking a given foreign language based on the information given in the table. How much greater was the median number of students taking a given class in 2020 compared to the median number of students taking a given class in 2021? In 2020, the median, so again, let's start with the minimum, 22. I'm going to eliminate that with the maximum, 72. Then I have 26. I'm going to eliminate that with the new maximum, 61. Then I have 37. I'm going to eliminate that with the new maximum, 50. So I have 48. Median in 2021, same thing. 23. I'm going to eliminate 77. 28. I'm going to eliminate 62. 38. I'm going to eliminate 50. And I am left with 44. The difference is 4. And it just so happened that Japanese was the median. But if you have questions on this one, you know what to do. It's not too bad. You just want to read carefully and understand what it's asking for. And now we have MM. What is the median of the data set shown? Okay, again, not too bad, except this time the numbers are out of order. Let's cross off 3 because that's the smallest, and 11 because that's the biggest, 4 and 10, 4 and 10, 5 and 9, and we're left with 5 and 6. So we just do 5 plus 6 divided by 2, 11 over 2. Obviously, you wouldn't have to write that out. You should just know it's going to be B as in boy, 5.5. I don't know about you, but I'm really enjoying these, honestly. They're kind of a pain to make, I'm not going to lie to you, but they're fun to do. What is the range of the values shown? Okay, so now we just need to find the biggest number and the smallest number. And you just need to be careful here. 104 is the smallest, and 124 is the biggest. So then we're going to do 124 minus 104, and that's going to give us 20. Okay, easy peasy beautiful. Easy breezy beautiful. That is a great. Okay, now we're on to the hard ones. Let's see just how hard these are. The box plots summarize the distance in meters a group of people ran in a certain amount of time. Group 1 is the group above, and group 2 is the group below. Based on the box plots, which of the following statements must be true? The mean distance of the group is greater than the mean distance of group 2. We can't really find the mean just from box plots, so it's probably not going to be that. The mean distance of group 1 is less than the mean distance. Again, probably not that. The median distance of group 1 is greater than the median distance of group 2, and the median distance of group 1 is less than the median distance. So they're using the same axis here, even if we can't totally read it. And this one is greater, right? The median is greater than this. So median of group 2 is greater than median of group 1. And that would give us D. The median distance of group 1 is less than the median distance of group 2. Okay, so we have questions on this one. Let me know. It's just about reading it carefully and understanding. Honestly, I think the hardest part is reading the answer choices carefully and not getting confused about which one's greater and which one's less in each option. So now we have HB. Dataset A consists of 10 positive integers less than 100. The list shown gives 9 of these integers from dataset A. The mean of these 9 integers is 87. If the mean of dataset A is an integer greater than 87, what is the value of the largest integer in dataset A? This, for my money, is probably the hardest question in this category. So what's happening is they're telling us dataset A, is what we're seeing, has 10 numbers. And we're seeing 9 of those numbers. And there's another number, let's call it X. Now, within X, something's going to happen. The mean of these is 87. We're going to trust that. If the mean of dataset A is an integer greater than 87, what is the value of the largest data in the dataset? So the mean is greater. So this has to be greater than 87 to push the mean up from the 87 it's already at. So we could find the value it is at, and it has to be less than 100, and it's an integer. So the current mean is 87. The new mean, we don't know what it is, but it could be 88, could be 89, could be anything. Could be any value above, but it wouldn't be above 100, right? Because X can't even be above 100. So let's say the new mean is 88. Okay, in this world where the new mean is 88, let's find the sum from the first 9 numbers by doing 87 times 9. Equals 783. 783 equals sum of 9. I know that because the mean is 87, so you just multiply that by the number of numbers to find the sum. Now, if the new mean is 88, we would just do 88 times 10 to find the new sum, and that's 880. And then we would subtract 783 from it, and we're going to get 97. So X could equal 97. If X is 97, that's bigger than any of these numbers, so the biggest number would be 97. Now, what happens though if we do 89? You're like, Sebastian, why can't it be 89? Well, I'll show you why. 89 times 10 gets us a beautiful 890. And when we subtract 783 from that, we get a lovely 107, but that's greater than the 100 they tell us about. So that's not going to work. X has to be 97, and that means 97 is the biggest value in these. So these conditions that feel kind of weird, they limit our answer to one option, and that gives us the answer we're looking for. So it's all about just reading carefully and not freaking out when it feels abstract, and just trying things out and then go from there. Now we have distribution category C for the new album by Bon Iver, Sable Fable. Different listeners gave it a different rating from 1 to 10. The table to the left shows the frequency distribution of scores of the 13 players in Group A and the 15 players in Group B. The median of the scores for Group B is how much less than the median of the scores for Group A. This is similar to the one we did earlier, except now we're dealing with frequencies. Also, this is a great album. Anyone who's giving it less than an 8, get out of here. Your ears have to get fixed. So we have a total of 15, so we're looking for the 8th person, and we have a total of 13, so we're looking for the 7th person. So the 8th person here, we go 1, 2, 4, 8. The 8th person gives it a 7. Unbelievable. And then here we have a 7th person. So 1, 2, 3, 4, 9. So the 7th person is somewhere here. It gives it an 8. Okay, that's a much more acceptable. So we would just do 8 minus 7, which is anyone? Right, 1, exactly. Okay. And check out this album. It is great. I would listen to From. That was one of my favorite songs on it, but honestly, the whole thing. The chart to the left displays the scores students in different classes give to Addison Rae's new album. Class 1 gives a mean score 0.2 points lower than Class 2. What is the value of X? So it's a mean score 0.2 points lower. I don't know about Addison Rae's music, so I won't judge the scores. So let's find the mean of class 1. Okay, so what we'll do is we'll add these together. You can do it in Desmos, and I'll give you 42.6. And we're going to subtract that from these. Or we're going to take these and subtract it. Now 42.6. And now we're going to add this on. We're going to add 1.2 onto that. Okay, so we're going to do, because we have 6 times 0.2, and that gives us 1.2. That'll be 43.8. Now we're going to subtract these from it to find the remainder, which would be the x value. So add those together and then take them away from 43.8, and you will get 7.1. X equals 7.1. All right. It's a little tricky, and you want to make sure that class 1 is 0.2 points lower. If it had been class 2 was 0.2 points greater, you would take away that value. So just be careful with the wording. Now let's go to E. A survey for favorite ice cream flavors across the nation has a median of 30%. The results from 8 cities are given in the table to the left. What is the difference between the median percent of the cities in the chart and the median percent of people across the nation? So across the nation, it's 30%. And now in the chart, let's see. So here we're comparing something in written form versus a table. So let's go lowest, I think is 23. Highest is 38. Second lowest seems to be 26.3. Second highest seems to be 31.2. Third lowest is 27. Third highest is 30.5. And then we're left with 28.3 and 29.9 as the two middles. So do 28.3 plus 29.9 and divided by 2. One thing I like to do sometimes is just find the difference of them. That could be easier. I can do that more easily in my head. 28.3 equals 1.6. I divide that by 2 and I get 0.8, and I just add that on to the 28.3 and I get 29.1. That's the middle. And that is, when we do 30 minus that, that's going to give us 0.9% as the difference. And that is A. And again, of course, you have your friendly Desmos to work with. Okay. So now we have F. Dataset A consists of the masses of 60 objects and has a mean of 30 kilograms. Dataset B consists of the masses of 90 objects and has a mean of 35 kilograms. What is the mean in kilograms of the two data sets combined? So if they were perfectly balanced, you could just take the means and find them if they were the same number of objects, but here you account for the different number of objects. So you do 60 times 30 plus 90 times 35. So you're going to get 1800 plus 3150. So you'll get 4950. And you're going to divide that by the total number of objects, which is 90 and 60, 150. And that will get you a nice clean 33. Okay, so the way you account for their different sizes is by multiplying each of them by the number they have of them and then dividing by the total number. And you can do that with mixtures, you can do that with this. It's something you do in chemistry. In chemistry, you can do it to find the average of isotopes or mixtures that you make. So it's something that's very helpful, actually. It's one of my favorite types of questions. Dataset A consists of 60 integers between 20 and 80. Dataset B consists of all integers in dataset A as well as the value of 90. Which of the following must be true? Mean of dataset A is less than the mean of dataset B. Range of dataset A is less than the range of dataset B. And median of dataset A is less than the median of dataset B. So dataset B is identical to dataset A except it has a 90 added on, so that will increase the range. So the range of dataset A is less than the range of dataset B is true. The mean will also go up. This is like when we did earlier. And then the median will not be changing. Or if it is changing, it's not going to be dropping. Although it won't be changing. So why am I even saying that? So it's going to be 1 and 2D. just read carefully what's going on and think about how dataset B is identical to dataset A, except you have a number that's bigger being added on. If it was a number in the middle being added on, then it's, I don't even want to say what it is because it's a bad word, but it's a thing, you know? All right. Then we have which frequency table to the left shows the dataset with the greatest mean. Are we going to find the mean? You bet we're not finding the mean. Because why do all that work? We're going to study the distribution and think about it like Einstein's. The mean here is going to be 2.5. So I guess I found it, but not really doing the math because it's perfectly distributed even. You see how they're all 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. We want ones where the frequency is highest at the end. So the frequency here is lower than at the end, so it wouldn't be that. It's actually, this one's higher, so it's not going to be that. Frequency here is high at the ends, but they sort of balance each other out, so this would also be a 2.5. But the frequency here, you're pushing it, and you're going to get more numbers are weighted toward the bottom, so we're going to have more numbers there toward the, not toward the bottom of the chart, but higher values, so it'll be C, because there's more big numbers there. If you think of 4 as a big number in this world of 1, 2, 3, 4. We don't even get to our thumb yet. So that's all you have to do. I'm not even going to bother showing you this because you got to just trust me. You could work it out, but you're just wasting your time. All right, so we have this lovely question here. 2 different teams consisting of 10 members each swam in a race. Each competitor's time was recorded. The mean of the finishing times for each team was calculated and is shown below. Team A, 5.56 minutes. Lovely. Team B, 6.65 minutes. A beautiful number. Which of the following must be true? Every member of Team A completed the race in less time than any member in Team B. Okay. There's at least one member of the Team A who completed the race in less time than any member in Team B. Okay. The median completion time for Team B is more than the median completion time in Team A. Then we have 1 only, 2 only, 1 and 2, and 1, 2, 3. So, is 3 true? No, because we don't know anything about the median. It could be true, but it's not necessarily true. Then is there at least one team member of Team A who completed the race in less time than any member in Team B. Okay, so what this is saying is that at least someone in Team A beat someone in Team B. And that has to be true, because if no one in Team A beat anyone in Team B, how the heck would they have a faster finishing time? So 2 is true. And then 1, if every member of Team A completed the race in less time. That's not necessarily true, just the average time, but not that everyone did it. So it's going to be B as in boy. All right, so now we'll go on to this. HJ, 2 data sets with 40 integers each are summarized in the histograms shown. For each of the histograms, the first interval represents integers greater than or equal to 0 and less than 10. And each interval after follows the same pattern. What is the smallest possible difference between the mean of dataset A and the mean of dataset B? So if you can see this, right, we have 4, 6, 8, 10, 12. There's 40 people, 40 here. And they're shifted on this one. It's to the left, 0 to 50, and here it's 10 to 60. So what is the smallest possible difference? So in this world, let's say everything is at the minimum here, and at the maximum on dataset B. That's how we're going to get the smallest difference between them. So we have to find min and max. So the min on this would be, we have 4 10s, 6 20s, 8 30s, 10 40s, and 12 50s. And the min here, and now the max here would be 4 9s, 6 19s, 8 29s, 10 39s, and 12 49s. Now what I want you to notice is how everything in this is 1 less than everything here. So then its mean difference is going to be 1. You could multiply it out, then divide by 40 and find it, but I'm not going to do that because you don't need to do that. So what you do, right, is you find the difference here is 1, 1, 1, 1, 1. So everything's 1 less here, so the mean would be 1 less. We're going to have C. Okay? As you can see on this test, on this category, there's a lot of hard level questions. There's more variety in the hard, so there's usually more types that I do for that. That doesn't mean that there's going to be more hard on the test. There's just more types you need to learn that are hard than the easy. The frequency distribution to the left summarizes a set of data where b is a positive integer. How much greater is the mean of the set of data than the median? Okay, so this is a bit more abstract again. We have 5b instead of actually finding it, but we have 5b, 4b, b, 4b, 5b. You see how it's symmetrical? And these numbers are all symmetrically spaced. They're evenly spaced. So then, like that one we did where there were 7 numbers that were consecutive evens, here we have consecutive odds. And because these are balanced, we don't have to find it again. It's going to be 105 for both of them, and our answer is D. If they weren't balanced, then you don't have to worry about the b's because they cancel out. You would just do 101 times 5, 103 times 4, 105 times 1, 107 times 4, 109 times 5. Add them together, and then divide by the sum of the 5, 4, 1, 5, which would be, 19, I think. So now we'll go to the next one. As you can see, these are conceptual. What makes them hard is they're conceptual. They're not hard to solve the regular way. They're hard to solve the fast way. And you want to solve them the fast way because on the test you'd have these, and then you'd have harder ones that actually would take a long time, and you need to save time for that. 2 box plots show the distribution of the number of movies seen by students over a weekend. What is the positive difference between the ranges of numbers of movies seen over the weekend? So here we're going from 10 to 3, so we have 7. Here we're going from 9 to 4, so we have 5. So then our difference will be 2. Honestly, I don't know why this one's considered hard because that feels pretty straightforward to me, but the SAT deems it so. Now we're talking. The frequency table to the left summarizes data on the mass of 47 objects. An object of 22 kilograms is added to the original data set, creating a new data set of 48 objects. Which statement best compares the mean and median of the new data set to the mean and median of the original data sets? So we're adding an object of 22 kilograms. Like the before, that's bigger than any of the masses we have. So let's see what happens here. The reason I have this as its own category is because it's a different type of chart. It's a frequency chart, but the concept is similar to what we did before. The mean are both greater. I wouldn't say the median. The mean and median of the new set are both greater than the mean and median of the old set. No, because the median isn't changing, I believe, but the mean is. The way we can find the median, 47 objects. This is an order from least to greatest, so we'll go to 24th object. So it'll be 10, 13, 21. The 24 and 25th objects are here. When we add in the new one, we're basically finding the 24.5 objects, so it's still 15. It's staying the same. Then the mean of the new set is greater, yes, because we're adding a bigger number than we had, but the medians are equal. That is true, so it should be B. The median and medians are both equal, no. And the mean is less than the old, but the median is equal, no. It's going to be B as in boy. Okay, again, we've done a couple that are like this with a different type of chart or data, but if you're adding a number that's bigger, you're going to be moving the mean up. If you're adding a number that's smaller than all the rest, you're moving the mean up without having to calculate. Don't calculate. Save your brain for harder questions. The frequency table to the left summarizes data on the mass of 40 objects. Which of the following could be the median mass of the 40 objects? So we have 40 objects. We want the 20 and 21st objects to find the possible means, or median. So 5, 7, 11, 17, all the way to 28. So the 20 and 21st object are all here in this category. So the value has to be between 21 and 25, and that is C. Nice and clean again. I'm loving these hard questions. I want you to be able to get 100% on these types of questions. So if you have any doubts, leave them in the comments. The dot plot represents a data set of the number of pets 27 students have in a class. If a new student joins the class and has 2 pets, which of the following measures will be greater in the original data set than in the new data set? The median or the mean? So there's 27 students. Let's see where the median is right now. We have 5, 9, and then the 14th and 15th are here. So if we add a person in, the 14th and 15th would still be here, and we are keeping the median the same. So it's not going to be median, so 1 is not going to work. But the mean is going to drop because now we're going below, right? We have a 2 here. So the mean will drop, so the original data set has a bigger mean. So it'll be B as in boy. Okay, again, very conceptual. Am I finding what the mean is? No. I'm not worrying about that. And I don't even care that much about the median. I just want to see if the median's an edge case where it might flip when we add a number in. But they're not doing that on this one. And that, ladies and gentlemen, believe it or not, is the last question. 39 questions. I know it flew by. I'm going to miss it too. If you miss it, you can just rewatch the video. But honestly, there's other videos to watch, other things to do with your life. So don't do that, but I wouldn't blame you if you did. I hope you enjoyed this video. I enjoyed making it. And if you have questions or doubts on any of these, put them in the comments. Or if you just want to say I'm doing a great job, you can put that in the comments too. I won't mind. So I hope it is sunny where you are. It is really hot in New York right now, but I'm hoping it'll warm up soon. And I had to turn my air conditioning off. Otherwise, it's too loud and I can't record. So I'm just making sacrifices for you all. I hope you appreciate it. And I'll talk to you soon. Bye.